let's say I want to calculate the 100th power of x plus y, and I want to know what expression I get, what sort of polynomial expression I get right here. What I could try to do is try to use the distributive property. So for the case of n equals 2, so here let's say n is equal to 100. For the case of n equals 2, we can have something like this, where we're choosing each term and we're going to multiply each term one by one. So I can choose x here and x here, which gives me, so I've chosen x and x, which gives me x squared. If I choose x here but I choose y here, I'll get, so there's a plus sign here, xy. So these are all added to each other, plus if I choose y here and then y here, I get y squared. And if I choose y here but x here, I get yx. And if I just add the same terms together, I get x squared plus 2xy plus y squared. And you see these coefficients here are what determine the sum, because here we have some x to some power k, and then we have some y to the power n minus k. Here k is equal to 2, n is equal to 2, so n minus k is 2 minus 2 is equal to 0, so it's x to the second power, y to the 0th power. And then the next one is 2 times x to k is 1, and then y is 1 as well. And then we have here, it's k equals 0, so this was k equals 1, and then if k equals 0, k equals 1, k equals 2, k equals 0 is x to the 0th power, 2 minus 0 is 2, so it's y squared, which is the same thing as right over here. Now, so we determined that our sum here will be some of these terms here, and what we want to determine is this coefficient right here. In order to determine this coefficient, we have to look at it in the general case. So let's just calculate this product where it has n many products. So just as before, we have these choices. We can choose an x here, choose a y here, again choose an x for the next one, y for the next one, and so on. So we want to get k many x's, and if we know the number of x's, of course we know the number of y's, because it's just n minus k. So let's say I want to choose 3 x's, and the rest of it would be n minus 3 y's. How many ways can I do that? If you remember our combinatorics, we have this notion of n choose k, which means the number of ways to choose k items out of n items. And we want 3 x's out of n items, and we don't care about the order. So this choice function, this n choose k function, doesn't really care about order. So we just write n choose 3, which is n factorial over 3 factorial over n minus 3 factorial. And we don't care about the order, because I can choose the x's from the first 3 terms, x plus y, x plus y, x plus y, and then the rest would be y's, and I would get x cubed y to the n minus 3. Or I can choose some random term here in the middle, and I can get x, and some other random term here, x, and then maybe I've chosen the first one to be the x, and the rest are just y, which gave me the same term, x cubed n minus 3. So, in general then, we can just choose k items, so it's n choose k, x to the k, y to the n minus k. And we've shown that all the terms are just the sum of these smaller terms, the whole power. So if I just add the summation here over all the different possible powers of x, which we can choose, we're free to choose, k equals 0 to n will be the answer to x plus y to the nth power. So we found this coefficient here, and now we can answer this question for the 100th power of x plus y. We just write simply sigma of k equals 0 to n choose k, x, and sorry, here should be 100. 100 choose k, x to the kth power, 1 to the 100th minus k power.